India is one of the worst places on Earth for ancient DNA to survive. Heat above 45 degrees, monsoon humidity, microbes that destroy organic material in decades. For over a century, archaeologists excavated thousands of skeletons from Indus Valley cities. Not one yielded usable DNA. Not one, which meant something unsettling. One of humanity's earliest urban civilizations, a society that built cities larger than ancient Egypt, might never speak for itself. And millions of people across South Asia might never know whether their ancestors built those cities or arrived later. This isn't academic. It shapes how hundreds of millions understand where they come from. Until 2016. Beneath the ancient city of Rakhigarhi in northern India, researchers uncovered a grave sealed for 4,500 years. At first, it looked ordinary. But one bone, smaller than your thumb, changed everything. The petrous bone, the densest bone in the human body. Against all odds, it still contained readable DNA. And that bone didn't just preserve DNA, it preserved a history we weren't ready for. A complete genetic record from the height of Indus civilization. For the first time, scientists could ask the Indus Valley people directly, "Where did you come from?" And the answer collides with what many of us thought we knew about South Asian ancestry. The discovery that defied odds. Rakhigarhi lies in Haryana's dry plains, once nourished by the Ghaggar-Hakra river system. At over 350 hectares, it's one of the largest harappan sites ever discovered, possibly larger than Mohenjo-Daro. But size wasn't what mattered most. What mattered was this. Rakhigarhi lies within modern India, within reach of advanced laboratories and international collaboration. Earlier attempts to extract DNA from harappan sites in Pakistan had repeatedly failed. Climate, logistics, politics. In 2016, a team led by archaeologist Vasant Shinde conducted a careful excavation. Burial 12 contained a mature individual placed in a flexed position with pottery typical of the period around 2500 BCE. Nothing unusual, except the petrous bone. This small pyramid-shaped structure protects the inner ear. It preserves DNA better than any other bone in the body. In hot climates, if DNA survives anywhere, it survives here. The sample was divided. One portion to Seoul National University's Ancient DNA Lab, the other to Deccan College in Pune. Because if this genome failed, the debate wouldn't continue. It would end. The 1%. Here's why this mattered so much. South Asia is a genetic graveyard. Out of 61 individuals excavated at Rakhigarhi, only one yielded nuclear DNA suitable for sequencing. 1. That's a success rate of about 1.5%. In Europe or Siberia, cold temperatures preserve DNA for tens of thousands of years. In South Asia, monsoons, microbes, and extreme heat destroy organic material quickly. The extraction process was meticulous. Samples handled in UV-sterilized clean rooms. Researchers in full protective suits. Multiple controls to detect contamination. One modern fingerprint would have destroyed the entire result. Even then, the genome was incomplete. Fragments damaged, coverage partial. But it was enough. After months of sequencing and genetic reconstruction, the team compared the Rakhigarhi genome against hundreds of ancient and modern populations from across Eurasia. And a clear pattern emerged, one that challenged how South Asian prehistory had long been understood. What the genome reveals. The results were published in the journal Cell in 2019. Here's what the Rakhigarhi genome definitively shows. First, no steppe ancestry. This individual carries zero detectable genetic contribution from Central Asian steppe pastoralists. The group's often linked to Indo-Aryan migrations. This matters. Most modern North Indians carry between 10 and 30% steppe-related ancestry. But at the height of Indus urban life, around 2500 BCE, it's completely absent, which tells us something crucial. The Indus Valley Civilization was built by populations already living in South Asia before steppe ancestry arrived. Second, a deep ancestral mixture. Roughly 60 to 75% descends from ancient Iranian-related farming populations. The remaining portion comes from AASI, ancient ancestral South Indians, hunter-gatherers whose ancestors had lived in the region for over 40,000 years. This wasn't a sudden invasion. It was a slow blending, happening over millennia, as farming spread and local populations mixed along river valleys. In simple terms, the Indus people weren't outsiders. They were already home. Third, genetic continuity. The Rakhigarhi profile is closest to modern South Indian populations, especially groups with minimal steppe input, which means the Indus people didn't vanish. They dispersed, they mixed, they endured. Their genetic legacy lives on in millions of people today. So the genetic story seems clear. But this is where certainty ends, the limits we must acknowledge. Because here's the complication. It's one genome, one individual, from one site. And one genome, no matter how extraordinary, has limits. It cannot tell us the language of the Indus Valley. The script remains undeciphered. Dravidian, Proto-Munda, something else entirely. DNA doesn't encode language. It cannot explain culture. Genes don't reveal beliefs, rituals, or social organization. And it cannot represent an entire civilization. The Harappan world stretched from Afghanistan to Gujarat, from the Himalayas to the Deccan. One genome from Haryana cannot capture that diversity. And finally, the absence of steppe ancestry in 2500 BCE does not mean migration never occurred. It means it happened later. Most evidence places significant steppe input between 2000 and 1000 BCE after the Indus cities declined. The genome clarifies timing. It doesn't rewrite everything, but it leads us to a deeper mystery: the knowledge that vanished. Around 1900 BCE, the great Indus cities began to empty. Not through war, not through conquest, but through environmental stress. Rivers shifted, monsoons weakened, trade networks fractured. People didn't disappear, they moved. East into the Ganges Basin, south into peninsular India. Their crafts survived, their tools endured, their DNA lived on. But their cities did not. No Harappan-style drainage systems reappeared. No writing system survived. No grid-planned cities rose again for centuries. If the people survived, why didn't the knowledge? DNA tracks populations, not ideas, not memory, not institutions. The Rakhigarhi genome has opened a door. It tells us who built the Indus cities, but not why they built them that way. It tells us they didn't vanish, but not why their achievements did. So here's my question. If you could ask the people of the Indus Valley one thing, what would it be? Their language? Their beliefs? Why they abandoned their cities? Or something else entirely? One genome has spoken. The others are still waiting.